Okay, we're going to start this second part by doing a couple of problems looking at the wheel and axle and pulleys. The first one is a crate of bananas weighing 3,000 newtons is shipped from South America to New York, where it is unloaded by a dock worker who lifts the crate by pulling with a force of 200 newtons on the rope. What is the AMA of the system? If the pulley has 15 ropes, what is the IMA? What is the efficiency? Now, one thing I didn't mention in the last slide as I was talking about pulleys is the the IMA of a pulley system is equal to the number of ropes that it contains. So the AMA is the force output divided by the force input. The IMA for a pulley system is the number of ropes, which in this case is 15. So here we have 3,000 divided by 200. And you can see right there that that's also going to be 15. So in this situation, it's unreal in the fact that this is going to actually have an efficiency of 15 divided by 15 times 100, or 100% efficiency. Now, obviously, that doesn't happen very often, like never. Now, here we have Jack and Jill went up the hill to fetch a pail of water. At the well, Jill uses a force of 20 newtons, so the input force here is 20 newtons, input, in order to crank a crank handle whose radius is 4 meters. So the distance for the input is 0.4 meters. And it rotates an axle, so the distance output is 0.1 meters. So she could raise the 60 Newton bucket of water, so the output is 60 newtons. So the question here, what is the ideal mechanical advantage of the wheel? Well, a wheel axle system, the ideal mechanical advantage is equal to the the radius of the wheel divided by the radius of the axle, which is the same as the distance of the input and the distance of the output. In this case, it's 0.4 divided by 0.1. So the AMA or the IMA is equal to 4. The AMA is equal to the force output divided by the force input, which is equal to 60 divided by 20, or 3. And then the efficiency of this system is going to be equal to 3, the AMA, divided by 4, the IMA, times 100, which is 75%. The next simple machine we'll look at is called an inclined plane. An inclined plane uses the length of the plane to raise a load a certain distance. So in this case, the output distance is equal to the height of the plane, and the input distance is the length of the plane. So an inclined plane is a sloping surface that allows for lifting of objects. These inclined planes were used to build the pyramids in Egypt. This is one of the ways they got these huge blocks up to where they needed them. As I said, the IMA is equal to the length of the plane, that is the input distance. The height of the plane is the output distance. A wedge, which is another simple machine, is just two inclined planes glued together, if you will. And the advantage here, again, is going to be the length of the wedge over the width of the wedge at its wide end. So the length of the wedge versus the thickness at the wide end is the IMA for a wedge. The third, that's another type of inclined plane, this is a screw jack, and this is essentially as any type of screw. Basically, it's an inclined plane on a circular inclined plane, for lack of a better statement. And so the height that you're moving is what's known as the pitch, which is the distance between threads, and the length is the circumference that you have to travel to meet one pitch. So a screw is a device that has an inclined plane wrapped around a central post, and the IMA is the circumference of the screw, which is the input distance, divided by the pitch, which is the distance between two threads, which is the output distance. So let's look at a couple of problems of this type. Clyde, a stubborn 3,500 Newton mule, refuses to walk into a horse trailer. So Farmer Brown must drag him up a 5-meter ramp, which stands 0.5 meters above the ground. What is the ideal mechanical advantage? If Farmer Brown needs to exert 450 newtons on the mule, what is the actual mechanical advantage? And what is the efficiency? So let's take a look at this. This is an inclined plane. It looks like just like this. The height here is 0.5 meters. The length is 5 meters. And so the ideal mechanical advantage is equal to this, which is the input distance, divided by the output distance, and you get 10 as your ideal mechanical advantage. Now the mule, the load is 3,500 newtons. The input by Farmer Brown is 450 newtons. And so the AMA is the output force divided by the input force, or the load divided by the effort, and this is going to be 3,500 divided by 450. So the AMA is equal to 7.78, and the efficiency is going to equal 7.78 divided by 10 times 100, or 77.8. So let's finish up by summarizing the various types of machines we've talked about here, and reviewing what the ideal mechanical advantage for each of these is. And we know that the actual mechanical advantage is always going to equal the force output divided by the force input. But in each of these, the ideal mechanical advantage represents the various ways that we can express the distance input divided by the distance output. So the first of these is the levers. We have first class lever, which is a seesaw. A second class lever here is a wrench. The fulcrum would be right where the bolt is, and the distance is very small for the output compared to the input, which is where you put your hand here. Or a hammer, which is a type of a third class lever, depending on how you grasp the hammer. And in every case, it's going to be equal to the distance from the fulcrum to the output divided by the distance from the fulcrum to the input. In the second class lever, it's the distance from the fulcrum to the output, which is a very small distance here, compared to the distance from the fulcrum to the input. Distance from the fulcrum to the input, which is when you put your hand, that's the input. So you have the mechanical advantage is the number of ropes supporting the load, and that's an important distinction. Because in a fixed pulley, there's two ropes here, but only one rope is supporting the load, and that's this one. But on a movable pulley, you have two ropes supporting the load, so the mechanical advantage ideal is 2 here versus 1 here. And then in a block and tackle setup, it all depends on how many are supporting the load, and it's going to be the ropes here, because this is not supporting the load. So you have 4 in this case. The ideal mechanical advantage for a wheel and axle is the diameter of the wheel divided by the diameter of the axle. Here's the wheel and here's the axle. Here's the axle and the wheel. And think of it as the fulcrum is the central axis that the circle rotates around. And one distance is the one arm of the lever and the other is the other arm of the lever. An inclined plane is the length divided by the height. A wedge is just 2 inclined planes taped together or pasted together, however you want to call it. And so it's going to be the length divided by the thickness at the thick end. And a screw is just an inclined plane on a circular rod. And so it's going to be the length of the screw, the circumference of the screw divided by the pitch of the screw. The circumference of the screw divided by the pitch of the screw.